till now what you have learned is just what the internal architectures of a line forward and then all forward robot. Okay, and also the coding of how to code those. So now we are going to see the actual 3D simulation of those two bots, like how it would look like if in a real environment. So the programming in Webots is not same as that of Arduino. It's completely different, but the programming language used is C. In Arduino also you are using C,
Your
and
voice
also you
is
are using
not
C.
that clear.
What?
Sometimes coming, sometimes your voice is not that clear. I think it's cracking.
Okay, okay. So I am now sharing my screen. Okay.
No, now it's okay.
Can you see?
Yeah,
Okay, so everybody now, have you all of you installed Weavers, right?
yeah, I have installed it.
Okay, so open it now. Here I'm going to show you the live coding of how to make a line follower robot. Okay, and if time permits, I will show the live coding of wall follower also, or else I will give you the code. You just copy paste it. So after opening it, go to the file. So if you see a black screen also, okay, if you see a black screen, then go to wizards and click on new project directory. And if you don't see, if you see that any kind of simulation is started, then go to file and click on new world.
Again, that audio problem started, I think.
So I can't help you. There's certain net issues here. So
Okay, okay.
okay, so can you see the screen, right? There is no lagging in the screen.
Mm,
Okay, all of you now go to wizards and then new project directory and click on next. Here you have to name your project. Like I'm giving it name SDV 2322. Okay. Then go to next. This is the arena. Like this is the arena where I'm going to create the environment of the line follower and the wall follower robot. So as you can see, this is the arena. And in the SDV workshop group, have you seen that there has been a Google Drive link has been shared regarding Webots?
While creating the project, you have checked all the four, right?
Yes, yes. Have you done? So now I'm going to increase the floor size, like 3. Okay. Just see that in the WhatsApp group, a Google Drive link has been shared. When you open it, you will see a PNG file. Okay, just download that file. That will be act as a track for this line follower robot. Is it done? Okay, you all can unmute yourself and interact with me. Just thank you. Okay, so after you have made this, go to floor and change it into a base node. Go there, URL. Okay. You will find that this kind of scene appears in the rectangular arena. This overline you see, this will act as a trap. And since I want to create one overline, I will increase the 5 total size. So I am making it like 1.9. Decreasing.
Dada, my that floor it's not showing in 3D like yours. It's showing in 2D.
You can just move it like that. Like click on the left click on the take the cursor on this floor and just left click and you can move it like this. 2D means I don't understand. Like everything here is a 3D dimensional. So like 3 dimensional,
Like
three coordinates will be there for everything.
it's only showing the top view, and when I'm moving, it's not moving like yours.
Okay, can you present the screen?
Yeah, okay, I'm presenting. Are you able to see it?
Yes.
So, okay, okay, okay. Understood now. It was that time I was doing like this, so it was sorry. I think I got that problem.
So all of you made this arena, like this track. Have you got? Have you able to? Were you able to do it?
How to change the floor?
हाँ भैया आफ्टर डाउनलोडिंग द पीएनजी फाइल के क्या करना है उसके लिए
Okay. So फिर मैं दोबारा दिखाता हूँ, ठीक है? This is what you have got till now.
हाँ हाँ मिला
Go to there and have you seen this floor appearance parquet tree inside the rectangular arena? Can you see this? Like go to the rectangular arena, expand it, scroll downwards, you will find this floor appearance parquet tree.
Yes, bhaiya.
So right click on it. Right click and convert this. Convert. It gets converted to a node. And then see this base color image. Go to URL. So are you able to proceed here till now?
Yes, bhaiya.
Just click on select and find out where you have downloaded. Mine is in download folder only. So if you select it and open it, it's not like this. So, like, okay. And since we want to make instead of four like, circular tracks, we want to create one. So that's why we'll increase the file. Okay. And just increase the flow. So this is the thing. So have you got it? Like make the float size to be X coordinate to be 2, y size to be 2, and float time size 1.7 MB. So I guess all of you have reached till here now. Now I am adding the inbuilt bot. It's called Inbuilt. So go to the plus sign and go to proto node, go to robots and GCtronic and click on add. Here you see inbuilt bot has appeared. And after epoch, go to like ground sensor slot and click on base nodes. And we have to add another base node, distance sensor node. Okay, so after that, like, yes, you have to change this distance sensor node to an infrared sensor node. Okay, or else it will by default it acts as a ultrasonic sensor. And name this like DS lab. DS left and translation to be like. Okay, so all of you reached here till now. So I guess all of you have reached here till now. So now I'm going to add a robot library. Okay, go to new robot controller here. We are using the C language, so that's why C is selected. No, Webots. My controller is finish. Just change this controller to go to spec and go to my controller here. So that is that whatever code you write, that code will be uploaded into this epoch mode, epoch bot. And there are certain libraries that you need to use. Okay, so to see, you have to use a function, you have to first import that functions library. So I'm here, I'm going to include the motor library now to increase to rotate the wheels of this motor, wheels of the epoch. Okay, so for that, and max speed I'm using like 6.28. So in Arduino, we have seen this thing, the void setup and void loop. So similarly in epoch also, this part is called the setup, where you initialize the variable and also set the the initial parameters for any devices that is assembled into this bot. And this is where the loop happens, like whatever the function is executed. Now I'm going to initialize the two motors. Okay, the two motors are like, the name of the two motors are the rotational left wheel motor 1, left wheel motor, and right wheel motor. So what I done here is that the left wheel motor and the right wheel motor are the names of the device, names of the motors that has been attached into this epoch board. Okay. So and the left wheel and right wheel are the variables that have been assigned to these devices. So whatever instruction I need to give to this device, or whatever instruction I need to take from this device, that instruction will be passed through this variable. Okay. And since it is a variable assigned to a device, that's why it's called the device tag. And W is the short form for Webot. Now I'm going to set the position. That means till what distance the wheel can rotate up to. Like in 3D coordinate system, till what coordinate the wheels can rotate up to. So since I'm to as much distance as possible, so I'm going to set that position to be infinity. So for that, I have a function called WB motor set position. That means it tells the bot that you can move up to infinity. There is no prevention in that inner movement. There will be no prevention in inner movement. That will similarly for right wheel also, I'm going to set the maximum position up to infinity. And the initial velocity, I have to give the value of the initial velocity. That means if I give certain like more than 0, it will automatically start moving without even executing what function is there. So that's why to keep it stop, and after the function here in this loop part gets executed, then only it will start moving. So for that initial velocity, I'm giving it to be 0. And this is a function for setting a velocity of the wheel. And so this is a save button. Like if you don't save and if you reset it, then it will move to the initial position, like what it was before, like the rectangular arena with checkered tiles. That position it will move into. So always save it. And after that, like I'm initializing the variable for speed, because the since speed can be like any value up to any, it can be a big float number also. For that I'm using the data type to be double instead of float. The initial speed I'm giving it to be like 3.0. And now I'm going to set the actual velocity, like at what velocity I want the bot to move. I guess this is the code here, and everything is done. So now save this code. Saved it and then build this code, like it has to be compiled. See, the bot is moving forward at a speed of like how much? 3.0. Okay. So since I'm not given assigned specified any sensor in front of it, so that's why it is not able to detect the wall in front of it. So it is getting stuck. It is getting stuck. Okay. And if you want to like make the bot move backwards, then what is that? The wheel has to turn backwards. For that, the velocity has to reverse. Like in vector, what you do in positive direction you give plus, and in negative direction you give minus. So this is also the same case. So -3 if I give it and save it, and then I compile the code. Just run, the bot is moving in the backward direction. So this is the case, and suppose I want to make the bot turn perfect, like 90° right or 90° left. So can anybody tell me what is the logic behind that? What logic should I apply? Like any one of you from the participant?
I think left.
Yeah, left wheel stops and right works. This maybe.
Giving negative to one wheel and positive to one wheel.
Yeah, like if I want to turn left, what shall I do then?
Give negative
Turn
to
left.
left wheel and positive speed to right wheel.
Left speed equal to 0 and right speed equal to positive.
Left speed
And if
negative
I,
and right speed positive.
yeah, you can give, yes, you can give either 0, or you can just rotate the wheel in the backward direction. One wheel in the backward, another wheel in the forward direction. That is also the same. And if I want to like don't want to take a sharp rotation, I want to take a like a long like radial curvature. Do that, then what shall I do?
Right speed, more velocity for right speed and less velocity for left speed.
Yep, absolutely. Okay, so this is the -3 I'm giving. It's turning, okay. And if I want to so it's taking a like radial curvature also. So that is over. Now I am going to initialize the distance sensor in the infrasonic sensor. Okay, here infrared sensor. Sorry, infrared sensor. So what that is that see the if you have turned this epoch into a base node, okay, so you can see inside the children, okay, the parent node is called the robot, and since all the components are assembled to make the robot, so the parent node is the robot, and the components are called the children node. And each children can also have its sub children also, since hinge joint is battery connector, and various components are assembled to make the battery connector. So each of its children are called each of its children are called the sub children also. That is the thing. And the infrared sensors are attached in the ground sensor slot. Okay, so for that, children distance sensor IR0, IR1, I've named them. Okay, so the like left IR0 and right one should be IR1. And if you go to view and go to optional rendering and if show distance sensor rays, you can zoom in and see that these are the distance sensor rays that can be shown. Yes, that it is emitting. And below, as you can see, these are the infrared sensor rays. Okay, below. So the infrared sensor rays that has been emitted. So for that, to use the distance sensor live functions, I have to import the distance sensor library. So the library name is distance. And now the device, the infrared sensors are named as IR0 and IR1, and I want to assign those devices to a variable. So for that, the same as then, the procedure is same as has been done for the wheel. So go to WB device tab. I'm giving it the name left IR, suppose. So like WB. And And as you can see that these are just an assignment. I just assign the device to this like variables, but the devices are not being enabled. So I need to enable the device in order to get what are the readings when the bot passes over this black line. Like if the bot passes over this black line, the readings would be more. And if it passes over the white line, the readings would be less. Okay, for the IR sensor readings. For that, I need to enable it. So the function is WB. So as you sorry. You can see I've written a time step here. The time step here denotes that after every 64 milliseconds, the this device will get new information. Okay. So the right IR will get new information and the left IR also will get new information. So within this 64 millisecond period, it will have to work with the older information that it has got. So I guess everybody has reached here till now. Okay. So if you haven't reached there, the code has been sent to you. You can just like copy paste and paste it until here. So okay, so do I need to wait or shall I proceed?
Please proceed.
Okay. Okay, now I have to get the values of the distance sensor. Okay. For this, the speed has been defined as 2. Okay, so sorry. I'm defining the same similar speed for both the wheels. The value of the distance sensor. The distance sensor values are quite large. Okay, so it can't be denoted by some float. I'm denoting it by double data type. These are the this is the variable I've assigned. Okay, left. So now I'm going to print these values. Okay, printf. So you all know that in C, if you want to print a double value, use the percentage %f sign. Left, right. And always after in the print statement, always give the end line character. Okay, or else it will not get printed because in this small console, it is not possible to print all the lines side by side adjacently. And for print statement, we have to in C, we have to import the library stdio.h. Now save it. Save this also. Um, you have to find out that at what is the value of when the board goes over the black line. Okay. As you can see here now, see these are the for this point of time what remains of the black line, and these are the values. The value is also called is 4 in 4 to like 12 to 14. Okay, 12 to 14. So somewhat around like 9 to 15. These are the values. So we have to in logic we have to apply that if the left tire value and the right tire value lies within this range and between 9 to 15, then you have to stay over the line, or else that you have to stay forward, or else you can move or go to the left or right.
Can you repeat that how to find that range, because there was some disturbance in the audio.
Okay. Yeah. So when I start the bot, it starts moving. So in the white line, as you can see, the values is between 4 and 5. And the range how you can find is WB distance and circuit value. This is the variable assigned to IR sensors, and this is the function which takes the variable values the sensor detects. Okay, is it clear to you now?
Okay, okay.
So when I stop it, the values, as you can see, when it goes over the black line, it is 12 and 14, 12, 11, 12 or something like it. It lies in between like 9 and 15 or something. This is the range. You have to apply this concept. Okay.
Okay, got it. Thank you.
So what I did is here is that this is a left line called a variable called left line. Okay. So if the value of the left eye sensor detected is between lies in between 9 and 15. Okay, so it has to the bot should get the information that there is a line on the left. The left eye sensor is detected a black line. There's a line on the left, and you need to shift leftward. Like you need to turn a certain angle to the leftward. And see, the data type I've used is bool is because if the value lies between 9 and 15, the left line would give the value 1. And if it doesn't lie in between, it will give the value 0. Because Boolean algebra, you have to study it in 12, I guess, in 12 physics. So it gives 0 and 1 value only. It operates in 0 and 1 Boolean. That's all. Similarly, for right line, also I'm doing the same thing. So this is now you have to apply the logic. Okay. So like as you can see is that the black line gives more value than when the bot was on white line. Okay. So if the left IR value is greater than, well, this has to be val. The left only without assignment name without the val is just like the assignment for the device, not the value. Okay. So the logic here is that the bot is moving. Okay, the left IR sensor and the right IR sensor detected the value, and it is found that the left IR value is greater than the right IR value. That means there is some amount. There may be a situation that there is a left IR sensor is detected a black line, and the right IR sensor is not detected anything. And also the left IR value lies within this range, like 9 to 15. So if that is within this range, then this left hand value would be 1, and 1 means true, and 0 means false. Okay. So this is also true, and this condition also satisfies. Then the bot should move leftward. So this is also the situation for same that if the right eye sensor has detected a value greater than left eye sensor, and the right eye value lies within this range, that it is a certain that the right eye there is a left line black line on the right, and the bot needs to turn rightwards. Okay. So let me see if what line follower works or not. As you can see, the bot is traveling over that line. So this is the concept of line forward bot. Like an actual self-driving vehicle, what happens is that the actual car detects the road and travels over it, and doesn't even like goes to the runs over to the footpath or like any other shop or whatever trees are present behind, present beside it. So this is what is the actual autopilot mode concept. Now, how much precision it can be done in this, how much precision the autopilot mode can be executed, that depends on the like whichever company is making the car. As you can see, this is the line follower model. You all can create this environment and copy paste the code that I've given here. The execute the simulation also live. And if you want, then you can also enable the camera here. This is, as you can see here, this is the camera. So for camera, you have to import a library called camera.h. Camera.h, and as you can see here, the camera, okay, the name, the device, the name assigned to this device camera is like this camera here. Itself is camera. So I am also using the name camera here. So similarly for motors also, I'm assigning a variable to this camera device. So this is the procedure. I'm assigning the variable name. I'm assigning a CM, suppose, and W. And I need to enable the camera. At this moment, the camera has been disabled, so I need to enable. So WB, sorry, camera enable. Okay. Function, and after enable means the camera will get new images after every 64 milliseconds. Like this is the timestamp I've given here. So after every 64 milliseconds, the camera will get new images and show it here. Okay, so like save it. Build the project. This is called the compilation of the project. Okay, and linking this code to this bot. As you can see here, this is the camera. Okay. But the picture you get is quite blurred. So that means you need to increase the height and width of this camera to get the more clear picture. And for this, you go to like width. Suppose I make it 640. And height to be also 640. The field of view is like a larger field of view I'm giving. That's why one. Just save it. Okay. Now like run it. So the camera is not at this moment. The camera is not working. I don't know why, but if you want, I can show you the actual model here. Like this is the camera, okay, and this is actually the what is this is the, as you can see, this is a wall followed bot. So okay, so this is the clear picture the camera will display. Now I'm going to show you how to design a wall follower bot here. Like I'm going to make you build a model. So go to plus and go to robot. Like I'm to, since I'm making a robot, so that's why the parent node has to be a robot. And the robot children are that the robot is consist of a body and the wheels. So those are children. Base nodes is like shape. Okay. And appearance, I'm giving it to be a PBR appeared. PBR appeared. PBR appeared is means that in actual real life, it will actually we can actually view this in the mode in which the device would appear in the real world. Okay, so that is called PBR. And I'm giving it the base color to be like red. Suppose any color like this one. And metalness, I don't want to be metalness. Okay, like I don't want it to be shiny, and I need to have some friction in there. Toughness. Geometry, the shape of that body has to, what I want is a box. I'm creating a box. So make it like size is 0.01, 0.2, and shape is over. Now I'm going to give the hinge joint, wheels. So wheels, like how is wheels? The wheels are attached to a motor, and the hinge joint acts as a. And the thing is that the hinge joint acts as a joint between the wheels and the suspension of the like a bot. Okay, so that is the hinge joint. Since I'm using 4 wheels, so I'm using 4 hinge joints. Give me the name of the shape to be like the shape of the body, so that is body. And hinge joint is the joint parameters I have to give. Like knowing joint parameters falls the axis of the wheel, and anchored means to which position the axis passes through the wheel. Okay. The axis is as you can see, the rightward direction is through which the axis of pass for this bot. So the rightward direction, as you can see, denotes the x-axis. So that's why the one means the x-axis, the x-axis is the primary axis, and there is no second y or z axis here. This has been calculated before, so this is a quite large calculation. You can go to the Webots site and see. Device is rotational motor. That is, it converts the electric energy into kinetic energy and makes the wheels rotate. Endpoint means the what will be the material of the wheels. Like the wheels has to be a solid. So that's why at the end of the hinge joint, the hinge joint would be attaching two solids, that is the board body and the solid wheel. Okay. So solid, and this is the shape I'm giving. Appearance is the same as PBRA appearance. Color I'm giving like blue. Roughness also, I want friction here. So geometry is like cylinder. Since the wheels looks, I have to be a cylinder, so it's a cylinder. And height of the cylinder, I'm giving it to be 0.02 and 0.04. Subdivision means how many divisions I want it to make the cylinder divide. Making it 24. Okay. The translation of this wheel is same as the anchor. So the anchor is 0.060, 0.0. So, and I applied physics here, so it will have its own density mass, it will gravity will act upon that solid. So that's the thing. Changing the, now I'm changing all the names. Similarly procedure, I'm to apply the similar procedure I applied for wheel one. Okay. Since the wheel one is at that side, so it will be minus. And the end point has to be like at the end of the hinge joint, there's a wheel, and wheel has to be a solid body. Children I use is that is, I don't have to again define the parameters here. Whatever parameters I used for wheel one, that same parameters will be used for every wheel, other wheel. Okay, as you can see here, the wheels are not like flat to the surface. Not, it has to be made perpendicular to the surface. So for that, I rotate the wheels, rotate it along like you can see z axis. Okay, so make it 0 and 1. Since you rotate it by 90 degrees, so the value of pi is 3.14. So pi by 2 is 1.57. It is rotated, and as you can see, this blue line points to the z direction. So this is the z, and arrowhead points to the positive direction. Okay, so similarly for every angle, 1.57. You have to rotate by 1.57 everything, and as you can see, the bot has been made. And don't forget, always try to save it. Okay, if you do not save it, the after resetting it, it will move back to its previous position, previous state. Okay, that means the bot will disappear from there. I'm setting the mass to be like 1, and I don't want density to be used here. So like it's -1 or something. Okay, now I have to apply the distance sensor now. So this is a children class. Go to like the wheel. This distance sensor here acts as an ultrasonic sensor. Okay, so like a children, like what shape do you have to give this? Like, so children has to be the shape. Appearance of the PPI appearance, like how do I want to look it in the real world, and give it an appearance like black. Sorry, do not has to be a box. Um, So everything is set. Now I'm going to write the controller now. So first I need to import two libraries here. So now I have to assign variables to four motors of the bot. I'm enabling the distance sensor here. After this, I'm trying to detect the values I'm trying to get the values detected by the ultrasonic sensors. So now I'm checking the logic is that suppose the bot is moving forward, and if it detects that the range between between the bot and the object in front is less than somewhat around like 1,000 meters, then it will turn right or turn left. Suppose I'm taking it to 950 and so this is a complete code. So I see that the bot has dipped a little bit downwards into the ground. So I don't know whether it will like work or not. I don't know whether it would work or not at this moment. There may be bugs, but since there is a time crunch, I wrote it fast. So let's see what happens. Okay, so there has been a problem with the hinge axis, I guess, but the distance sensor, as you can see, is working. So I can, so it is detecting the wall and avoiding. Okay, with the line followed as it is, it's working. So I can show you a clearer picture here. And this is the, as you can see, it's a wall follower, and the line follower is also moving, and the wall follower is moving along the wall. So this is the scene. That, so at the end, actually, like this is just a miniature version of what a self-driving vehicle would look like. So actually, this is the what a self-driving vehicle is actually. As you can see here, this is a vehicle moving on the wall, and as you can see, there is no driver present here. See, there's no driver. This is the road, and the vehicle will detect this yellow line and go over it. And if they find any obstacle in front, it will overcome it. So I'm starting the simulation. It has various sensors situated at sideways and rear also, and it also has a PID controller here. See, like it will avoid the obstacle. Okay. See the obstacle, it detects the obstacle and moves over besides it. So this is what is actually a self-driving vehicle. Actually, what do you mean by this? The workshop self-driving vehicle.
Your video is lagging, Bhaiya.
Lagging maybe due to net issues, but you are able to understand that there is no driver present in the seat and the car is moving on its own with this yellow line. So I guess this was what was all about the self-driving vehicle workshop. So this is the end.